Welcome, Matthew Mathers. Last lesson was absolute value. But previous to that, we had done a lot of work with equations in the last month. So today we put that together and we have absolute value equations. So basically, you find solutions of an equation. It can be any number that makes the problem true. So for a problem like this, there's for absolute values two numbers that will make these be true, usually. So for this, if we put in the bars a 10, that would be an answer, because the absolute value of 10 is 10. But the absolute value of negative 10 is also 10. So a problem like this, we're not looking for one answer anymore, we're looking for two. If you want to write this in a fancy way, you could write plus or minus symbol, and then write 10 once. It's a little shorter way to write the same thing. So if this were an 8, you'd say plus or minus 8. This is 7, you'd say plus or minus 7. Whatever this is, most of the time, you'd say plus or minus that number. One exception would be this. This actually has no answer. Anytime the bars are alone and they're trying to equal a negative number, that cannot be done. And that's a math symbol there that means I just can't do this. Because if you put in a positive number, you get out a positive. If you put in a negative number, you get out a positive. There's no way you can put in any number and get out a negative here. So if there's a positive number here, you get two answers. If there's a negative number here, nothing. The only exception to those rules is if I gave you 0, that's the only problem that would have one answer, just 0. Because there's no plus or minus 0, that's not a thing. So 0 here would just be 0. Here's a slightly harder problem because the bars are not alone. So if we had to solve this, we would do what we've been doing. The equation is still like the scale, we're still doing the opposites, we're still, whatever we do to one side, we have to do to the other to keep it balanced. So if you see adding, you'd have to subtract 5. If you subtract 5 to get rid of the 5, the 7 would turn into a 2. And then you do what we did up above. The answer would be positive or negative 2. This number is multiplying, so you have to divide. So you want to get the bars alone. If this is multiplying, divide by 4. Dividing by 4 makes the 20 become 5. The answer there would be positive or negative 5, which I'm going to write this way. But if you'd rather write this way, feel free. But that would take you through column 1 of the worksheet that's titled Absolute Value Equations. That would get you from 1 to 10. 1 to 10 are different, and they're in the same column as each other because it's only the x that's in bars. When you step to 11, you might notice there's a lot of stuff, or more than just a single variable in the bars. There's not just an x anymore in there, there's an x plus 3. So this is going to have a different approach. What we're going to have to do for a problem like this is make ourselves two problems. Copy x plus 3 twice. In one of the problems, let it equal 7. In the other problem, let that equal negative 7. Turn one problem into 2. The bars go away when you take one problem into 2. And then solve them each. Subtract 3 here, we get you a 4. Subtracting 3 here from negative 7 would take you all the way down to negative 10. If you're already negative 7, and subtract 3 more, you're down to negative 10. As always, you could check those. If you put the 4 in, 4 plus 3 is 7, and that's good. Negative 10 plus 3 would be negative 7 temporarily, but the bars would make that 7, and we have two true answers. If I had thrown a negative right here, you should rejoice because you would just write, I can't do this, and move on. So if this is a negative 7, you would just do the no answer symbol, move on with your day. That's a better deal. So for this, same kind of scheme. We're going to take the one problem and make it 2. The x minus 2 is unchanged. Whatever is in the bars, you do not change that. Copy it twice. Where it's different is after the equals. 4 for one version, negative 4 for the other version. And then do opposites. Adding 2 here gets you 6. Adding 2 to negative 4 would get you a negative 2. Because when you add 2, depends on which one's bigger. The negative is bigger, so negative answer. We subtract, and it's in the 2 family. Last one, same kind of thing. Again, copy the 2x plus 3 twice, exactly as it is, unchanged. The only difference to the two problems we're making, one has an 11, 1 has a negative 11. If we subtract 3 first, when we do our opposites, we add or subtract first. So if we subtract 3 first, 11 becomes 8. Divide by 2, the 8 would become a 4. And again, you could check it. 2 times 4 is 8. Add 3, it is 11. We wanted 11. That's good news. Here, if we subtract 3, we have to be a little more careful. We're already negative, so we go all the way down to negative 14. If negative 11 subtracts 3 more, all the way down. And then 2 is trying to multiply, so you divide, always opposites, and we'd be at negative 7. And those are the two answers. Negative 7 checks, because 2 times negative 7 is negative 14. Negative 14 adding 3 would get back to negative 11. And the bars make it 11. That all works. That's the way you should go from 11 to 30. There are a few that I can see on 11 to 30 where I sneak a negative in over here. And if I sneak a negative over there, again, celebrate. No answer symbol, move on. So any of these that have negatives on this part of the world, that's good news. Other than that, I think we look good. 11 to 20 should be just single step problems where you're either going to add or subtract. And then starting on 21, there are these 2-step problems where you have 2 opposites to do. Add or subtract first, multiply or divide second. If that's not enough, send me an email. I'll answer questions later. See ya.